Lindsay from StatsMedic, and in this lesson we are learning about the power of a significance test. So we just have one learning target, and that is to interpret the power of a significance test and describe what factors affect the power of that test. All right, so we are sticking in this context today. This is, I think, the last time we will talk about whether or not I'm a good free throw shooter. So I want you to start by recalling that I claim I'm an 80% free throw shooter. Mr. Wilcox is skeptical. He thinks I am less than an 80% free throw shooter. So I've decided to take another SRS of 50 free throws to prove myself. So number one, we're going to start by writing appropriate hypotheses for the significance test. Make sure you're defining your parameter. And then I would like you to work through question number 2 as well. So we've learned about type 1 and type 2 error. So I'd like you to take a minute and write your hypotheses for question number 1. And then in context, write question number 2, describe what a type 2 error would be. All right, so on number 1, I started by defining my parameter, which is P, the true proportion of free throws made by Mrs. Gallus. My null hypothesis is that P equals 0.80, and the alternative is that P is less than 0.80. Now, one thing I'd like to add to this is just putting it into context. What does this mean? I find that really helpful, especially when you're getting into describing your type 2 error after this, but then also when we get into our interpretation and a bit about power. So on my null hypothesis, if I say the proportion equals 0.80, what does that mean in context? Well, if this is true, what it means is that Mrs. Gallus is truthful. So I am telling the truth when I say I'm an 80% free throw shooter. And then my alternative, if I'm actually less than an 80% free throw shooter, then we would say that I am exaggerating or I am lying. Okay, so for my type 2 error, that helps me out then, because what I'm thinking about here is a type 2 error is when the alternative is true. So I started by writing Mrs. Gallus is less than an 80% free throw shooter. So I've restated my alternative hypothesis. So I'm going to put that here. Just a little note to myself. This is my alternative hypothesis. So what should you do if the alternative hypothesis is true? Well, you should reject the null. However, since this is an error, that means we did not do what we were supposed to, and instead we fail to reject the null. Or in other words, you think, well, Mrs. Gallus is telling the truth when in fact I'm actually not. So now what we're going to do is we're going to think about, okay, well, that's a bad decision, right? We don't want errors to happen ever. So what we're going to do is we're going to go to an applet. So we're starting here at number 3. It says to assume Mrs. Gallus's free throw percentage is actually 66%, meaning the alternative hypothesis would be true. So what I'd like you to do then is you're going to go to this applet. All right, so the applet looks like this when you get to it. You can click here, like enter numerical value for the null. Remember the null we said is 0.8. So you can fill that in by typing it. Your alternative hypothesis is less than, and so on. So what I'd like you to do is to take some time and fill in all of the information into this applet. And then to complete just question number 3. So 3A, B, and C. And we'll work through those first, and then we'll come back to the applet to finish up question number 4 as well. So take a few minutes to work within here and get all the information you need to answer question number 3. All right, so before we get back to the note page, I want to point out what your applet should be looking like. So you've been told to enter in all the correct information. So we've got the null hypothesis is 0.80. My alternative hypothesis is a less than, and then they give us down here this true value of P. So we've said in the problem that my actual free throw percentage, the truth is that I'm a 66% free throw shooter. So I put that in here. My sample size of 50 was already there. And then my type 1 error or alpha, well, that's 5% that we're using as our cutoff. So what I've done here then is it said to click the type 2 error. And I can see now, if you look up here at the top, they give me the probability of a type 1 error is 5% or our alpha level. Now they're giving me the probability of a type 2 error is 24. And then the power is 76%. Well, let's go back to our notes then and we'll kind of break some of this down. Okay, so in part A, we are asked if HA is true, what is the probability of a type 2 error? So that we got from the applet. They told us it was 0.24. Now in B, it says, okay, well, if the alternative is true, what is the probability of a good decision? So what I want to think about here is, well, if the probability of a bad decision is 24%, well, then doesn't the probability of the good decision have to be all of the other options? Like I can either make a good decision or a bad decision. I can't do anything else. So if there's a 24% chance that I make a bad decision, then there's a 76% chance that I make a good decision. So what I'm noticing here is that on the applet, it said power 76%. And then in B, it's really saying, well, in other words, a good decision is 76% as well. So what that means is this part B, this is actually this thing we call power. So next to part A, I'm going to write this is a type 2 error. And so a type 2 error, again, is when the alternative is true, but we make a bad decision. So what is power? Well, then power is the flip side of that. The alternative is true, but we make a good decision. And you'll notice over here that these two things add up to 1. They're complements. So type 2 plus power equals 1. Okay. Now, I do want to point out one other thing that was important is we did have to enter in my true free throw percentage, this 66%. So what I want you to do over here to the side is I'm going to note that in order to calculate power, you must have a specific alternative value. So without that alternative value, we can't actually calculate what that probability is. Okay, so on part C, we're asked to interpret this probability. Interpret the probability of a good decision in the context of the problem. So what I've got here is, well, remember, we're doing this all under the assumption that I am a 66% free throw shooter. So this first part here, if Mrs. Gals is a 66% free throw shooter, well, really, isn't that a condition? We think back to probability. This is really a conditional probability. If I am a 66% free throw shooter, there is a 0.76 probability that we make a good decision, or in other words, that you decide correctly, that I'm exaggerating, meaning you reject the null. So what I'd like you to do over here next to part C is I'm going to write this as a conditional probability. This is the probability that you correctly reject the null. So the probability of rejecting the null given the alternative is true. That is what power is. Power is the likelihood of rejecting the null when the alternative is true. All right, so now we want to think about, okay, well, how can we increase that power? If this is a good decision, we want that likelihood to be as high as possible. So what I'd like you to do is to go back to the applet and fiddle around with this sample size, alpha level, and the alternative P, meaning the alternative true proportion. Move those around a little bit and see what happens to your power when you manipulate those amounts. All right, so let's see how we can increase the power of a test. So in the applet, if you adjusted your sample size, you hopefully found that when you increase your sample size, you increase your power. Now, when you adjusted your alpha level, hopefully you also saw that increasing your alpha level also increased your power. And then the last one, your alternative P, meaning originally when we were looking at power, we said that I was a 66% free throw shooter. If you make that even smaller, like 60% free throw shooting, for example, then the power went up as well. But what I want to do is I want to take a couple of minutes to talk about that. So let's look back at the applet. And so what the applet is showing me here is I have these two different normal curves. Now the normal curve in red, that is if the null hypothesis were true. So if I really were an 80% free throw shooter. So when we are conducting this test, we start by assuming the null, which means we are assuming this red normal distribution. That is the truth, is what we are assuming. Now, the question is, well, when can I reject that null? And I can reject that null when I get past my alpha level. So when I get within that lower 5% of that red curve, well, then I can reject the null. So what I want to do here is I want to take that picture in the applet and put it onto our paper. So I'm going to start here by drawing a normal curve, and this normal curve is going to be the normal curve for the null hypothesis. Now, if the null hypothesis is true, we're assuming I'm an 80% free throw shooter. Well, now when you're calculating power, we have to have an alternative value, and our alternative value here we said is 0.6. So I'm going to draw that second normal curve, and I'm going to draw it below. And so 0.66 is the actual true proportion. So what I want to think about is, okay, if we have assumed the null hypothesis, when do I get to reject the null hypothesis? So the rejecting of the null hypothesis depends on our alpha value. So what I want you to do here is draw this, and I'm going to label this as the cutoff to reject the null. Okay, well, you can see here, if the truth really is 0.66, I could land in that normal curve in this area down here. And if I actually landed in that area down here, I'm going to mirror that up here. This overlap, this overlapping amount, that is our type 2 error. So the goal is we want that overlap to be as small as possible. Because if I land anywhere over here in my normal curve, that means I'm going to be past that cutoff, and then I'm going to be able to reject the null. And this green area, this is power. So what we're thinking about is, okay, when is that overlap as small as possible? So when you go back to thinking about sample size, why would increasing sample size increase your power? Well, it's because when you increase your sample size, you decrease variability, which decreases the overlap. Those normal curves are both going to get more narrow, so the overlap is going to get smaller. Okay, what about the alpha level? Well, if I increase my alpha level, what I'm going to point out over here is that it would be like this or so. Okay, well, increasing that decreases the overlap, but additionally, it makes it easier to reject the null. So what I'm going to write by this one is that this makes rejecting HO easier. And then on this last one on part C, we said that you wanted to lower or decrease that proportion, that alternative proportion. Well, in this case, it's only decreasing because that is separating the normal curves more. So really what I want to put here is that it's not just that we are lowering P. What we're doing is we are increasing the distance from the null. So to summarize, what I'd like you to put here down at the bottom is I'm going to put to increase power. You have three options of what you can do. One is to increase your sample. So I'm just going to use arrows. I'm going to say you increase N, your sample. You increase your alpha level. And then also you increase your distance from the null. All right, let's go through the important ideas. Okay, so what I like to do when I'm thinking about power is I want to think about, okay, what are good decisions and bad decisions when we're doing a significance test? So when you have a significance test, there are 4 different options of what could happen. So I'd like you to draw this grid. And what I want to think about here is, okay, well, what is the truth? And it's either that the null is true or the alternative is true. Those are our only options. Okay, now on the other side, what I want to put here is what decision is made. So for making decisions, we can either reject the null or we can fail to reject the null. And what I want to do is take a second here and think about, okay, which of these decisions are good? So for example, if the null hypothesis is true, what should we do? Well, we should fail to reject the null. That is a good decision. So what I'm going to do here is I'm just going to put a smiley face. That's good. That's a good decision. Okay. Now, if the null is true, but we reject the null, that is a bad decision, and that is a type 1 error. All right. What if the alternative hypothesis is true and we reject the null? Again, that is a good decision, but more importantly, that is the power of the test. And then the last spot, if the alternative is true and we fail to reject the null, that is a type 2 error. So what that means down here is the probability that you make a type 1 error, we talked about this before, that is your alpha level. The probability that you make a type 2 error is 1 minus the probability of the power. So we talked about on the last page how those are complements. All right. And then the other very important part of our learning targets today, we're interpreting power. So I like to start with the probability notation. So it is the probability that you reject the null given the alternative hypothesis is true. So if I think of it as a conditional probability, it makes my interpretation a little bit easier. So when I'm writing a conditional probability, I would start by saying the condition. So I'm going to say if HA is true, and then we do want to give add a specific value in context. So if the alternative is true, there is a blank probability of finding convincing evidence to reject the null. And we do want to put the null in context as well. Now in that blank up here, that is the power. So whatever value you have been given on that. Now I will say it would be very, very unlikely that you'd be asked to calculate power by hand. You could of course be given the probability of the type 2 error and then be asked to find the complement, which would be the power. But other than that, it'd be very unlikely that you have to calculate it yourself from scratch. All right, and then our last part here was about increasing power. So to increase your power, you can increase your sample, increase your alpha level, and increase your distance from the null, or in other words, increase your distance to the alternative. So the distance between the alternative and the null, the farther away they are, the better. All right, I would like you to take a few minutes and work through the check your understanding problem, and then let's go over the answers when you're ready. All right, so in part A, we are asked to interpret the power. So again, thinking of it as a conditional probability, what we are told is that the true proportion is actually 0.70. So I'm going to say if the true proportion of guests that will attend the wedding is 0.70, there is a, and then power, which is 0.10, there is a 0.10 probability that we'll find convincing evidence to reject the null, which is that the proportion of guests is 0.75. All right, for B, we're asked to find type 1 and type 2 error. Type 1 is our alpha level, which we're told is 0.05, so I just filled that in. And then type 2 error, remember, is 1 minus the power, so 1 minus 0.10, so our probability of a type 2 error is 0.90. And then in C, you've been given a couple different scenarios and you have to decide if you're going to increase or decrease power. For the first one, using a lower alpha is going to decrease power. It makes it more difficult to reject the null. And then in the next one, the sample size has been increased. When you increase your sample size, you increase power. So power would go up in that scenario.